In note 6.5, day 2, example 3, we're going to build a graph of secant x. And to begin with, we're going to graph the graph of the reciprocal function, which is y equals cosine x. So I'm going to put a scale on the y-axis. I'll do 1 square is 1 unit. And then we're going to start graphing cosine. We know that cosine x starts at a maximum at 0, 1, and then there are key points every quarter period, which is every pi over 2. So it starts at the maximum value, then it would be at pi over 2, 0 at the midline, pi, negative 1, 3 pi over 2, 0, 2 pi, 1, 5 pi over 2, 0, 3 pi, negative 1. And if we go in the negative direction, we'll be at negative pi over 2, 0, negative pi, negative 1. And I'll connect these with a dashed line with a nice smooth curve with rounded turns. And this will be y equals cosine x. Next thing I want to do is I want to get a few points on the secant graph, which is the reciprocal cosine. So I'm going to look at the unit circle up here. So negative pi over 3 is this point right here. Actually, I could put the angle in. I didn't put that in. So this is negative pi over 3, coterminal to 5 pi over 3. And the value for cosine at negative pi over 3 is 1/2. So we'll put that into our table, which means secant of negative pi over 3 will be the reciprocal of 1/2, which is 2. Cosine of 0 is 1. So we'll put that into our table, which means secant of 0 is also 1. Cosine of pi over 3 is 1/2. So secant of pi over 3 is 2. Cosine of pi over 2, the x-coordinate on the unit circle is 0. And that means the secant of pi over 2 is undefined because it would be 1 over 0. And cosine of pi, the x-coordinate on the unit circle is negative 1 here. That means secant of pi is also negative 1. And now we are going to graph secant x. So everywhere that cosine x is 0, that's when secant x will be undefined. So it'll have a vertical asymptote. So when graphing secant, I am going to put in vertical asymptotes at every x value where the cosine function is 0. So I'm going to have a vertical asymptote at x equals pi over 2, x equals 3 pi over 2. I'll have another one when x is 5 pi over 2. Again, these are values where the cosine function crosses through the x-axis or its midline. So x is negative pi over 2. So those are vertical asymptotes. Now let's plot a few points that we have from our table. So negative pi over 3, the secant value is 2. So we'll put that on here. And then we've got 0, 1. That's a maximum, that coincides. Maximum of cosine is the minimum for secant. And then we have pi over 3, 2. So I'll put that point on my graph. And now I can see, just like when we graph cosecant, that we have this U-shaped curve between negative pi over 2 and pi over 2. And then we can copy that into the next interval. So in the next interval between pi over 2 and 3 pi over 2, the U-shaped curve is going to be going downwards. So we're going to have a graph like that. We're going to have the point 2 pi 1, and then we'll have the U-shaped curve going upwards. And then 3 pi negative 1, the U-shaped curve going downwards, negative pi negative 1, and we can draw half of the U-shaped curve on the left side of the graph. That is the graph of y equals secant x. Let's analyze the characteristics, just like we've done before. So the domain is going to be all real numbers, except values where the vertical asymptotes occur, which is where cosine x is 0. So it's all real numbers, except x is not equal to, and now we can see some of those values, negative pi over 2, pi over 2, 3 pi over 2. So to express them all, we can pick one value. I'm going to pick pi over 2. And then we're going to add an integer multiple of pi, so plus pi n. And then we need to say where n is an integer. The range, so if we think about the range, we're going from negative infinity up to negative 1. Then there are no values between negative 1 and 1. And then we have from 1 to infinity. So the range is going to be negative infinity to negative 1, square bracket, union, square bracket, 1 to infinity. The period is how long it takes to complete one full cycle. So I will highlight one cycle here. So we can do this part going up, that branch, and then this branch going down. So that interval is going from negative pi over 2 to 3 pi over 2. So that's taking a total interval on the x-axis of 2 pi. If we want to change the period, we'd have a horizontal dilation. And this period is the same as the reciprocal function, which is cosine x, which makes sense. X-intercepts, do we have any? So where does the graph of secant x cross the x-axis? And we can see it never does, so there are none. Okay, vertical asymptotes, those are the values we just excluded from the domain. So it's going to be x is equal to pi over 2 plus pi n, where n is an integer. And then I'll scroll up a bit. Local maxima, so those are the highest points in an interval. So I'm going to circle a few of the local maxima. So this is a local maximum, that's the singular. So that's a local maximum. So we've got local maximum at negative pi, negative 1, pi, negative 1, 3 pi, negative 1. So to get from one value to the next, we are adding 2 pi. So if we want to express, have an expression for all of these values, I will pick one value. So I'm going to pick pi. And to that, I have to add an integer multiple of 2 pi. So it's pi plus 2 pi n, negative 1, where n is an integer. And local minimum, or minima, that's the plural. So I'll scroll up a bit. Local minimum values are the lowest point in some interval. So I've highlighted 2 local maxima value. Oh, sorry, those are minima values. So these are local minima values. And let's list those. So the local minima that we can see on the part that we graphed are occurring at 0, 1, and 2 pi 1. So to get from one to the next, we're adding a full cycle, or 2 pi. There would be another one if we continued on at 4 pi 1. So to express all of these, we can pick one. I'm going to pick 0. So we would say 0, which I won't write, plus 2 pi n. So it's just 2 pi n 1, where n is an integer. And is this function odd or even? So if it's even, it has y-axis symmetry. And if it's odd, it has origin symmetry. And if we think about folding this graph upon itself over the y-axis, we can see that it does indeed have y-axis symmetry. So I am going to say that secant x is even because it has y-axis symmetry.